Hello and welcome to Minimizing User Impact with Advanced Restore Methods. My name is Bob Pusateri, and to briefly introduce myself, I am based in Chicago, where I am heavily involved with the SQL Server and data platform communities. I've been working with SQL Server and the data platform now for about 15 years, and the most valuable information you will find on this slide is my contact information. If you have any questions following this session that we don't have time to get to, or if you're watching this video later and would like to reach out, please feel free to reach me via either Twitter or my email address you can see on the slide. I also have a link here to my blog where, once again, you can find contact information for me should you like. Our agenda today is to cover restore methods that are a bit more involved than just a simple restoring a backup. These are point-in-time restores, page restores, and piecemeal restores. We'll cover why you would want to use these and the conditions that would bring them about and the advantages they offer over a regular backup and restore setup. This is the point in the presentation where I would ask if anyone has ever lost data to please raise their hand. Sometimes people do raise their hands, and I like to point out that if you haven't lost data yet and you've been working as a database administrator, you're either lucky or you're lying. I think everyone will lose some data at some point in their career. This isn't a bad thing. These are bad days, but hopefully the big takeaway is that we learn from them, we learn how to prevent them, and that helps us all get better and progress throughout our careers. How can we help prevent data loss? Well, backups are going to be your bread and butter, right? But having backups are half the battle. Knowing that you have backups that are running correctly, that are scheduled at the right intervals, and backups that you know can be restored because you've tested them is something that's incredibly valuable. Aside from that, having a big toolbox of restore techniques is also incredibly valuable. You need to know what these techniques are and know when to use them and how to use them because you've practiced them. Usually when you're needing an advanced restore technique, you've already suffered some sort of disaster or downtime. There might be a system not available at all. You may have higher-ups from your organization reaching out to you wanting to know how fast you will be able to bring things back online. And being able to tell them something like, I can have the database back in 30 minutes because I know it, I've done this before, will look incredibly good for you. So I recommend having these techniques, being familiar with them, practicing them, having run books for them, because once again, if a disaster is striking and you're a bit flustered and stressed, having stuff written down is going to be very helpful to you. There's lots of fancy ways you can get higher availability with databases, right? You can deploy log shipping or availability groups or other tools that will help. But at the end of the day, there's still no replacement for having a proper backup and being able to restore it. In fact, you may end up having to lean on that regardless. So in that sense, I like to think of restores as being the Real McCoy, right? This is a saying that's usually attributed to a Canadian-American inventor named Elijah McCoy, who had numerous inventions for lubricating different parts of steam engines. But one of their sayings was always ask for the Real McCoy. So I like to think of restores as a Real McCoy as well, whereas you should not accept any substitute for being able to restore. All that being said, not all disasters are the same. There are certainly different kinds of disasters an organization can encounter. Maybe a giant tornado comes and blows your data center away, right? That's definitely a disaster. In some cases, that could be considered an easy disaster because everything's gone. That's a terrible disaster, but it's simpler than some of the other scenarios you can arrive at. Maybe, things melt in a data center, and I've literally seen this. We have trees here in the U.S. called cottonwood trees, and when they let loose, it's the equivalent of cotton balls flying around in the air. And I worked for an organization where a data center's cooling system sucked in a whole ton of cottonwood seeds, and it clogged the cooling system and killed the air conditioning in the data center. And unfortunately, one of the first servers to fail was the email server, so there were no alerts going out telling anyone that the temperature in the data center was getting too high. And by the time they finally figured it out and someone went in the machine room, there were literally plastic parts of servers that had melted. It had gotten so hot in there. You can encounter, network going down, storage going down. There's plenty of other situations. Disasters happen for a wide variety of reasons. Some you won't believe until you actually encounter them. I had one employer where we had a data center go down because rodents chewed through cables in the wrong location, right? So there's too many disaster scenarios to list here, but some of the ones we're going to talk about today are the disasters that you can't exactly prepare for or can't exactly expect to encounter. So one of my favorite types of disaster, and it's important to remember that this is a disaster too, is the oops, I ran a delete without a where clause, right? This is a bit different than a server exploding or a data center disappearing, because the data's there, you just deleted it or logically corrupted it for a lack of a better term. The data's now wrong. It's still intact, so it will probably survive your high availability systems, but we have a big problem. So if a data loss occurred a certain period of time ago, and we have the situation where the data that's been entered since that time can also be lost, and we need to bring the entire database back to a point in time before this disaster occurred, well, we have options. Now, I should point out that if the database is in simple recovery, you have a lot fewer options. Right? If the database is in simple recovery, you can restore the database to the point of your last backup, but you don't have transaction log backups, so you lose a lot of flexibility. And you're potentially going to lose more data than you needed to be because you don't have point-in-time recoverability when your database is in simple recovery. But if it's not in simple recovery, well, then we have more options. Now, there's lots of different combinations of backup types that can be restored, right? You can restore a full diff backup, you can restore a full and apply a differential to it, you can apply log backups to a full backup or to a combination of full and differential backups. So you have different combinations of backups that can be restored. Point-in-time restore does not work for all of these. It only works for restore combinations involving a transaction log. You have to have a transaction log to be able to do a point-in-time restore. Can we do a point-in-time restore with a full backup? Yes, but only if we have a log backup as well. If you only have a full backup, then this isn't something you can do. Now, for point-in-time restores, you actually have three options of when to or how to use them. You can use an argument called stop at, which will stop the restore of the transaction log at an exact date and time. So if you happen to know when a disaster occurred, you can run your transaction log restore and tell it to stop before that disaster occurred, and you'll see that in one of the demonstrations. There's also the stop at mark and stop before mark options you can pass in. These let you stop the restore either at a transaction, at a named transaction, which you'll see in a demonstration as well, or at a specific log sequence number if you have to read the transaction log. And stop at mark will let that transaction complete and then roll back, or start before mark will roll back to immediately before that transaction occurred. So these are the options you have for when you're running a point-in-time restore. And this is a valuable type of restore to have for those what I call OSNAP queries, for the oops, I didn't mean to delete that table. Or perhaps if you have deployments that have gone bad. So with that in mind, let's go to our first demonstration and take a look at how a point-in-time restore works. So here's our first demonstration on point-in-time restores. As you can see, I'm running this demo in Azure Data Studio, and I'm connected to a SQL Server 2019 instance that's been deployed in Azure. The demonstrations you're going to see will certainly run in any supported version of SQL Server, and actually many older versions that aren't supported anymore. I can comfortably tell you that everything I do here will run in SQL Server 2000, and I certainly hope in this day and age that nobody is running anything in SQL Server 2000 anymore. So we're going to start by restoring our demonstration database. It's a pretty small database, so it will back up and restore really quickly. And it's called demo data. So I'm going to go ahead here and restore the backup of this database. Now, this database is set in the full recovery model, However, the database, after being restored, will not really behave like it's in the full recovery model until a full backup has been taken. So the first thing I'm going to do here is take a full backup of the database to make sure it's running in the full recovery model. And I'm also going to take a transaction log backup as well, just so we have that out of the way. Now, the data we have in this database is zip code data, so United States postal codes. Just to briefly show you what it looks like here, it's a simple table. It's got a couple thousand rows, 41,000 rows. It has 4 columns, an ID, the zip code itself, and then the city and state that the zip code belongs to. If I were to query here all the zip codes in the table for towns named Brookfield, you'll see we get several entries. We have Brookfield, Connecticut, Brookfield, Georgia, Brookfield, Illinois. We also, at the bottom here, we have Brookfield, Wisconsin, which is a larger town, and larger cities in the U.S. might have multiple zip codes. So just to show briefly what this data looks like. So let's say now we have our business with our zip code data, and we're going ahead and making changes to this data as part of our normal business operations. So I'm going to update Brookfield, Illinois zip code and change it to all zeros. And I'm also going to delete zip code 60515 because the business need to do this apparently. This is a valid change. Now when I run this delete, I'm also going to capture the execution time that this statement ran. We're going to need that in a moment. You'll see why. So now let's make a mistake and introduce a mini disaster to our environment. Let's say that there were some data entry problems for the state of Washington and the state was not capitalized. So we're trying to fix this case sensitivity error. So we're going to issue an update and set the state name for Washington to be capital WA, except we screwed up and we forgot the where statement, right? So now instead of updating just the rows for the state of Washington, we've updated every row in the table, all 41,000 of them, which we clearly did not want to do, right? At this point, our data is invalid, and this is a major problem. If we were to query the table, we'd see that, oops, literally every city is listed as being in the state of Washington, which we really don't want. So now that our disaster has occurred, one of the best things you can do as soon as you realize that you've run into a disaster type situation is back up the transaction log of the database, right? So we're going to back up that log, and we're now going to have a transaction log backup that covers the period of time that our disaster occurred in, right? This is crucial to any kind of recovery effort. Now that we've gotten that backup, we're going to actually go ahead and restore this database on the same server to a database with a different name. We're going to call it demo data _restored. Now I just ran restore file list only to show you that we have multiple files in this database, and restoring it, I'm going to use the move command just to specify exactly where those files are going. Because it's being restored on the same server, we'd run into name conflicts otherwise. So I've restored the database. Now I need to restore the transaction logs, and you'll notice there are 2 of them, right? There's the one transaction log backup we took right after we restored the database to begin with, and then there's the transaction log backup that contains our disaster. So we're going to go ahead and we're going to copy and paste the time from immediately before that disaster occurred into the statement here. And what we have is we're restoring the transaction log, but in the last line you can see we're using the stop at statement, and we're saying restore this transaction log but stop at this time, and the time is immediately before that disaster occurred. So this will restore all the transactions from that transaction log backup up until that point in time at which it will stop. This will get us back all the transactions that we want and none of the ones that we don't. So we're going to restore that with a stop at command. We're going to recover the database, right? Restore with recovery. This allows us to query it once again. And now that we've restored this demo data restored database, we're going to back that one up as well, right? So that we have a good place to move forward from there. So we're going to back up this database and its transaction log as well. So now let's go ahead and query this data that we just restored. We're going to use the demo data restored database, and we're going to select from our zip code table, and we can see that all is well and good. We have, once again, our state names are fixed Not every state is the state of Washington anymore, which is exactly what we wanted. And also, if we were to query for zip code 60515, we will see that it does not exist, which was the last change we made to this database that we intended to make, was deleting that one. So we've captured all of the changes we made up until the point when the disaster occurred. Right? This is great, and it's probably your number one restore method I would recommend using if you know when the disaster occurred. Right? Unfortunately, we can't always know exactly when the disaster occurs. Hopefully we do. If we don't, the next thing I would do would say go ahead and see if you have any kind of audits running on your server where they capture the statements, who ran them, and hopefully what time as well. You can use your audit information to determine what time you should put in that stop at command. If you don't have an audit for some reason, well, you're starting to run into a trickier situation now. One thing you can do is look at the transaction log, and you can do this using a function called fn_dblog. If you select your database name and then select from that function, it will return the actual contents of the transaction log. Now, the transaction log is not a pretty thing to look at. It does not contain nice, easy-to-read statements like, oh, this is an update statement. The transaction log contains logical commands. So if you say update this row, you will see in the transaction log things like modify a row or acquire or release a lock, things like that. But it's not a nice, easy thing to look through. That being said, you can read through the transaction log if you're in a desperate enough situation and kind of figure out where this disaster might have occurred at, and the log sequence number you can use to restore up until that point. Another action I'm going to demonstrate for you right now is called mixed transactions, marked transactions. I can't read my own writing. Marked transactions are you literally can mark a transaction with a name in the transaction log, and it will appear when you read the transaction log. Like you'll notice right here, there happens to be a named transaction visible. So SQL Server ran a transaction called auto-create QP stacks and named it, and it's marked in the log and such, and you can see the beginning time as well. So you have that information if you use a marked transaction. So to do this, we're going to use our database that we just restored. We're going to begin a transaction, but we're going to give it a name. We're going to call it update state. So we're beginning the transaction that is named update state with mark. That is very important. That's what actually marks the transaction out in the log. And you can optionally give it a description as well, which I did here, but you don't need to give it a description, but you do need to say with mark. So we're going to go ahead and use that database and begin our transaction. And now we're going to run a command. We're going to update some zip codes, and we're going to set zip code 60513 to be all zeros. When we're done making that change, we're going to commit our transaction, but because we started the transaction with a name, we need to commit it with one as well. So we have commit transaction update state. So now we've run a command within the context of a marked transaction. At this point, we're going to run another transaction. This one's going to be unmarked. Another mini disaster here. We're going to change all these state names to Oregon where they were formerly Washington. So we did that. We just updated 716 rows. Oops, didn't mean to do that. Let's take a log back up again, covering the period of time for the disaster we created. There we go. So now we're going to restore our database. We have into a third database called demo data restored 2. So we're going to run this and restore that database. We're going to restore the transaction log that we ran immediately after we created it. And now we're going to restore the log with the stop at mark. So as you can see, and as I've notated here in the last line, we're restoring the log with no recovery with a stop at mark of update state. So this will apply all the transactions in the log up to and including this named transaction. So now we've restored everything in the log up to that named transaction. We're going to bring the database online so we can query it. Go ahead and refresh up here so you can see I now have 3 copies of that database. And if I were to select from it and select my zip codes, you'll notice everything is right with the world once again. And zip code 60513 will be correct because we fixed it there. All right, and if you want to see a list in your database of all the marked transactions that have been created, if there are any, you can actually select from the table msdb.dbo.log mark history. So if I run this query here, you'll see that the update state marked transaction I created with a description was created by me. It's in this table and it contains both the time and the LSN as well. So that's kind of one of the advantages of marked transactions, is you have a table in MSDB containing all that data. And that concludes our first demonstration. Now, in conclusion, point-in-time restores are great. They're probably the most common type of advanced restore method I've ever needed to use in my career, but I would like to point out that they are never a substitute for proper planning or testing of backups. They're also not object-level recovery, and I've gotten this question several times, so I wanted to touch on it really quickly. When people are looking for object-level recovery, they're usually looking to recover a single object, like a single table, from a database backup file. This is not something that SQL Server will do natively for you. This is usually something that you would need a third-party piece of software to do. There used to be a lot of third-party software for object-level recovery out there. It seems like a couple of the options have disappeared over the years, but I believe there's still some out there. The native method for doing this would be to restore a full copy of the database to another location and then copy over the objects you need back into your database. This, of course, can be difficult or challenging if your database is huge, but if your reason for being unable to do this is that you don't have enough spare disk space to perform this type of restore in your environment, that should be a red flag in the sense that you should have enough disk space in your environment to restore your production database somewhere else should the need arise. So let's move on to our second disaster scenario now, and you'll see what's on the screen. What is that? Well, that's the output of a DBCC checkDB command that has failed due to corruption, right? So we're going to discuss what happens if we discover corruption in a specific location in our database. Now, to review very quickly, SQL Server database files are divided up into what are called pages. Every page is 8 kilobytes in size, and I believe it's been that way since SQL Server version 7. It's been quite a while, so anything you should encounter in the wild at this point should be made up of 8 kilobyte pages. In our scenario here, DBCC checkDB has found one corrupt page in the environment, right? So boom, there's a corrupt page on the screen now. Problem is, this is a really large database. Let's pretend this is a 20 terabyte database. And yes, we have restores and they're all good and tested, but it takes 5 hours to restore this database. Do we really want to kick all our users out and have to take a downtime for 5 hours to perform this restore? Now, maybe if we're in an environment where we have 5 hours, we can take a downtime, or we're not being used overnight or on a weekend, this wouldn't be terrible. But we have better options. Instead of restoring the entire database, which we certainly can do, what if we just restored the individual page or pages that were corrupt, right? And this is what a page restore does. It is much faster than a full restore because we're not restoring the entire database. If you're using Enterprise Edition, you can actually keep the rest of the database online while you're doing this. This is a nice Enterprise Edition feature. Sorry, if you're using Standard Edition, then the whole database has to go down, but only for the period of time you're doing the page restore, which will likely be much shorter than restoring a full database, especially if it's large. Extra bonus for doing a page restore is, you might impress your friends, but this depends heavily on who your friends are. But if you have the type of friends who are attending a conference like this, then yeah, maybe they'll be impressed. So let's take a look now at a demonstration of SQL Server page restores. We're going to start off this demonstration once again by restoring a fresh copy of our demo data database. And while that's restoring here, I'm going to go ahead and update the Object Explorer so we can see it on the side there. Now this time we're going to create an index, just one, on the city name column of our zip code table. So we have an index that we've created. And now we're going to go ahead and run the full backup and the transaction log backup for this database, so we have those at our disposal. There we go. So let's find a single record. And when I'm looking for a single record, I tend to use a town in Illinois called Hoopeston, simply because it's a very unique name. It's the only city in the country with that name. So if I select from the zip code table where city name equals Hoopeston, I get only one row back. It's zip code 60942. If we want to find out what physical data page of the SQL Server data file this record lives on, we can use a special feature in SQL Server called Fizzloc. So if we say %% Fizzloc, and add that as a column, so we're selecting star, comma, Fizzloc from our table, we'll see the record, and we'll also see this Fizzloc column show up here. Now this is a hexadecimal value, unfortunately, so not very user-friendly, but there's also a special function we can plug in called sys.fn_Fizzloc cracker and pass the physical location value into this function, and it will go ahead and translate that for us into 3 easy to read and understand columns here. We have file ID, page ID, and slot ID. So now we can see that the record for Hoopeston, Illinois lives on file number 3 in page 153 at slot number 82. That is the exact location of that record. Now let's go ahead and take a look at that page. And if you've never done this before, we can use a command called DBCCRightPage to actually read an individual data page. You have to pass in the database name, the file number, the page number, and then a final argument that says how you want it returned to you. Number 3 is usually what I use. This will print out the entire page with some helpful annotations so you know what you're looking at. And to be able to run DBCCRightPage, or at least to be able to see the output it returns, you need to enable trace flag number 3604. So I'm going to go ahead and turn on 3604 and run DBCCRightPage. And as you can see here, we now have the contents of this page printed out. We have the buffer, we have the page header, and then we actually get down and we have the individual rows. So we can see right here we have a zip code ID for zip code 60643 in Chicago, Illinois. So you can actually see every bit of data on this page with some helpful annotations through the output from DBCCRightPage. So now that we've read this page, let's corrupt it. And this is something you should not play with in production or development environments. I hope it goes without saying, but I'm using a command to do this called DBCCRightPage. And DBCCRightPage is a command that's not logged. It directly updates the data page to whatever you tell it to update. It does not update the checksum of the page unless you tell it to update that as well. So what that means is, and what I'm utilizing it for, is the fact that I'm going to make a single byte's worth of change to this page, and the checksum will no longer match. Therefore, it'll be seen by SQL Server as a corrupt page. If you were to use this command on a database, it actually sets a flag in the database saying DBCCRightPage has been run, and if you were to call Microsoft support about that database, they would take a look at that flag and be less likely to help you as a result because you were using undocumented commands you should not be using. So only use this in an environment where you know you can play around safely. So what I'm going to do here is I'm going to alter the database demo data and set it to single user mode. And then I'm going to run DBCCRightPage, and you pass in the name of the database, the file number, the page number, the offset you want to write at, which is 2560 in my case. I'm writing 1 byte, and that byte is the hex value 4F. So I'm going to run that. And now I've just altered this page. And if I go back, I can read the page. That's not a problem, because when SQL Server parses the page like this, it isn't looking at the checksums. And now I'll set the database back to multi-user mode, and we can resume our querying. So let's see what we did here. If I were to select from the table with cities named Brookfield, like I did before in our last demonstration, that works fine. But if I were to select the record for the city named Hoopeston, which is the value I just changed, and thus corrupted the page, SQL Server tries to read that, and it's going to freak out with a logical consistency-based I/O error for incorrect checksum, because the checksum no longer matches. right? This is a problem. This is corruption. We just literally corrupted this database. This page is now seen as being suspect. So if we were to select from the msdb.dbo.suspect pages view, we would actually see this page listed as suspect here. So file ID number 3, page ID number 153. And if I were to go ahead and run a DBCC checkDB on the entire database, this consistency check will also fail because, once again, we have a corrupt page in this database. So I achieved my goal. I corrupted the database on a single page of my choosing. Now that this has occurred, let's try to fix it. So I'm going to start once again by taking a transaction log backup of the database, right? Because that's one of the best things we can have is a log backup up to the point of failure. And now we're going to do a page restore. So we're actually going to take the backups we have and only restore that single page. And the syntax for this is the same, pretty similar to the other database restore syntax. So we're going to restore database demo data. We're going to put a page argument in there. So page equals 3:153. So just page 153 in file number 3 from our backup file, from our full backup. So let's run that. And now what's really neat is we're now in the middle of a restore, right? There's a restore going on. I haven't recovered the database yet, so the restore is not complete, but the database is still online. So if I were to go to another session and just simulate the behavior of another user running a different query, so I've opened up another session here. I'm just going to select where the city is named Brookfield. That's going to run just fine because that's not affecting, or that's not using the page that I'm in the middle of restoring right now, right? That's pretty cool. If I were to go here and change the name to Hoopston, which is the page that I'm restoring right now, and try to select that, I'll get an error that says that the page is marked as restore pending. So you cannot run any queries that will read that page, but literally any other query that will touch somewhere else in the database can run without being affected by this. That's pretty neat. Now that we've actually restored that page, we need to replay the transaction log going back to the point where that full backup was created. So in my case, I need to restore both of the transaction log backups that have been taken in that time. And now we get to the part that most people forget about. Once you've restored these transaction logs, you're in great shape, but you still need to finish by taking another transaction log backup to cover the activity you just created by making that change and doing the restores, and then restore that backup immediately as well. And you restore that with recovery, and that brings the database back online and available to everyone. So if I back up my log again, and now I restore what I just backed up, now we have completed this single page restore. Did we fix it? Well, let's see. Can we query the database for Hoopston? We absolutely can once I selected the database. Sorry about that. There we go. I can select the whole table, and I can select the row for Hoopston as well. So we have successfully mitigated this crisis of corruption in a single page by restoring that single page. Now, a couple things I'd like to point out. This was an online page restore. This is an Enterprise Edition only feature. If you're running Enterprise Edition, you can do exactly what I did here and not affect any other users that aren't trying to read that page. If you have Standard Edition, you can still do this, but the whole database will be offline for the duration of that page restore. If you want the extra uptime, that's an Enterprise feature still as of SQL Server 2019. If we didn't have a recent full backup, we would have to restore a lot more transaction log backups, which could take more time. So that's something to keep in the back of your mind, a recent full backup or a differential backup. If we were in the simple recovery model, this would not be possible at all, right? We have to have the transaction log in play to be able to do a single page restore. And if this happened on a non-clustered index, if you find corruption in a single page and that page is on a non-clustered index, probably before I went to the single page restore, I would just try dropping and recreating that non-clustered index. And finally, one more thing I'll point out is that if you encounter situations like this where you have random pages that weren't corrupt before that suddenly pop up as being corrupt, this is probably indicative of a bigger problem. If this were the case, I would definitely be looking to engage my storage team or whoever's responsible for my storage subsystem, because the vast majority of corruption issues you encounter in SQL Server will likely be caused by something somewhere in the storage subsystem. So while you can definitely fix this problem using the technique I just showed and be able to move forward, you would also as well want to be looking into what is the root cause here, how do we fix this? Because if it happened once, it's likely going to happen again. Now, page restores are a great technique to have in your tool belt, especially in cases where you have corruption that is very localized or can be isolated and the database is still online. Now let's move to our next scenario, a disaster where our RTO does not allow enough time to restore the entire database for a situation where we need it. This is normally the time for an in-person presentation where I would ask who here has an RPO or an RTO established. Ask for a show of hands. If I'm lucky, it would probably be about half the room. Now, if you're not familiar with these terms, RPO stands for Recovery Point Objective, and RTO stands for Return to Operation. These are time values that are established, and this is usually a business decision. So this isn't something the IT department should be making in a vacuum. You definitely need to work with the business end of your organization and try to arrive at a solution for what is an acceptable amount of data loss and an acceptable amount of downtime should a disaster occur. Now, it's very easy, of course, for the corporate types to say, hey, we're not going to allow any data loss and any downtime at all. We just need 100% uptime because, some of the major internet companies already do that, so why can't we? But of course, the truth is that if you want zero downtime, it's going to get very expensive very quickly. So that might be something to stress to them. Now, to show this graphically here, we have a timeline. The blue line in the middle is the timeline, and we have a disaster that occurs. Now, RPO, the recovery point objective, is how much data is it acceptable to lose before the disaster, right? Maybe you have an RPO of 1 minute, 5 minutes, 15 seconds. Whatever your RPO is will help determine what your backup strategy is, because you need to make sure you don't lose more data than your RPO allows. Similarly, your RTO, or your return to operation time, is the amount of time it takes to recover from a disaster once it has occurred, right? If your RTO is 2 hours and you can't restore your database in less than 6 hours, you have a problem, right? This is where you need to go back and re-architect your restoration methods, maybe have a chat about is our RTO reasonable given the size and complexity of environment now. But these are not purely business decisions and not purely IT decisions either. It needs to be work and a solution come up from amongst different teams. Now, one solution you can use to try to help the situation where your RTO is not long enough to restore the entire database is to plan out what's called a piecemeal restore or a partial restore. This lets you bring part of the database online. Now, there's a couple requirements for this to work. You need SQL Server Enterprise Edition, first of all. So once again, if you're using Standard Edition, I'm sorry. You also need multiple file groups because you need to have, you're going to bring part of the database online in terms of file groups, right? So you want to make sure you have your file groups divvied up in such a way where you can bring certain parts online, and then you need to make sure that your objects in your database are divided amongst the file groups correctly so that you can bring a single file group online and be able to do everything you need to do. So it requires planning, multiple file groups, and Enterprise Edition. But the idea here is you can bring the most important critical data online first, bring on that one file group or a couple file groups online immediately, and then once that is recovered and back online, you can bring other data later. So maybe it can be agreed upon in your organization that the accounting data from 2 years ago and older can wait if we absolutely have to bring other things online first, and can agree that, yes, we'll get this other stuff online within, 5 or 6 hours after we've recovered the truly critical information. Piecemeal restores are great when your database is already offline and you need to bring it back online in an organized manner. And like I said, when you have RTO requirements to meet, that's a real big driver for when I tend to look at piecemeal restores. And with that, let's take a look at how a piecemeal restore actually works. I'm going to start once again by restoring our demo database, and then I will run a full backup of it as well. And now that I've made a full backup, I'm actually going to insert a new record. This time, instead of using zip code data, I have a smaller database of vehicles that were towed. So we're going to add a new vehicle to our list of vehicles that were towed in this particular table. So there we go. We're going to back up the transaction log to reflect this change. And now we're going to add a second vehicle to the vehicles towed table and back up the transaction log once again. Now for a piecemeal restore, it helps to understand how your file groups are set up, because this will determine what you can restore in a piecemeal fashion. So the first thing I'm going to do is look at sys.filegroups and just see how many file groups we have in this database. As you can see, there are 3. There's the primary file group, which of course every database has. And then I have 2 additional ones, one for the zip code data that we were experimenting with in the previous demonstrations, and a third one for the vehicle towing data. If I were to run another query here and join database files to file groups, we can see which files live in which file group there. So we have the primary database, or the primary file group, which is named demo data. There's the zip code file group, has a file named zip code data, and the towing file group has a file named tow data. This next query here will just show me which tables reside on which file group. This is a very small demonstration database, so I only have 2 user tables, but we have towed vehicles and we have zip codes. Towed vehicles is in the tow data file group, and zip codes are in the zip code file group. So now that we've made some changes to the database, we've backed up the transaction log, and we understand the file groups, let's simulate a disaster by just dropping the whole database. Whoops, there we go. All right, so the database is gone. Now we're going to do a partial restore, and we just want to bring the towing file group online. Now, with any partial restore, you have to bring the primary file group up to begin with. So we're going to start by doing restore database demo data file group equals primary. That means this is a partial restore now, just of the primary file group from the file with partial and no recovery. So we've started this restore. We're also going to bring the towing data online at the same time. So we're going to run the same command again, except now we're just going to specify towing data or tow data as the file group. Now we have both of these file groups that we're bringing online as part of a partial restore. We need to restore our transaction logs as well. And once we've done that, we can restore the database with recovery and bring it back online and make it available for querying. So as it sits right now, the towing data file group is online and able to be queried. If I were to look for one of the license plates or one of the vehicles we added to the towing database, it would show up just fine. But the zip code data has not been brought online yet, right? This is where if I were to select from the zip code table, I'll get an error saying this table resides in a file group that is not online. The advantage here is if you have a lot of data that you don't need to bring online immediately and a certain amount that you do, you can only bring on what you need. So at this point, I needed the towing data more than I needed the zip code data. So the database is partially online. The towing data is available. Zip code data is not. Now let's say that at a later point in time, we want to bring the zip code data online as well. We can do this at any point in time later by once again running restore database for the file group zip code data this time. Now we need to apply all of the transaction logs covering the period of time from when the full backup was created until the present. So we'd have to apply all of them. In my case, there's only 2. But here I'm applying the transaction logs, and now I'll restore the database with recovery. And now that I've done this, the zip code data is online as well. So I've fully brought the database online. But as you can see, I brought the towing data online first, and that was available to anyone, whereas the zip code data was not. So if you're really pressed for time in your restore scenario, you can bring part of the database online and leave the rest until a later point. And that concludes our demonstration of piecemeal restores. Now, moving on, one final point I'd like to touch on is that of third-party backup tools, and I know I mentioned these already slightly before, but please remember that third-party backup tools may or may not offer these same capabilities I just showed you that SQL Server native backup and restore has. Some of these tools offer advantages over SQL Server and some don't, so you really need to know what you're working with. If you work in an environment where you already use third-party backup tools, it'd be a good idea to review their capabilities in terms of advanced backup and restore methods. And if you are considering purchasing one, or your organization is considering purchasing one, these are great questions to ask, is what do they offer in terms of the ability to back up and restore a database. Some of these tools may offer them, some may not. Some may try to tell you that you can solve all the problems of the world with a storage snapshot, which I would be very leery of. But these are things you need to test and see. So in conclusion, have backups. Not only having backups, but have backups that you know work because you validated them via restoring. And have backups that are scheduled and running at the proper intervals to deliver the proper level of restorability that your organization requires or that your clients require that you're managing for them. Have a big toolbox of restore techniques available to you, including the lesser known advanced restore techniques we discussed here today, and practice them. Be familiar with them. These are not things you want to be learning about as you're frantically reading through documentation because a disaster is currently going on. These are things you want to have some familiarity with and know what to expect and know what you can do with them, because frankly, these are the things that make the difference between a good employee and a true senior DBA who can make a difference for the organization. So I know we're done a little bit early. I'm going to give you some time back. But before I do that, I just want to point out thank you very much to Microsoft. Thank you for supporting Data Platform Geeks and SQL Server Geeks community initiatives, including this conference that we're all at today. There are a couple different ways you can win prizes. Remember, you can post a selfie with hashtag DPS2020. You can give session and conference feedback, and I'd particularly want to encourage you to do that because we're all looking to learn here today, including the speakers, and a lot of speakers are looking to perfect their craft, and the best way to do that is with honest and constructive criticism from attendees. So please, if you have feedback, I know I personally would very much value it, and I'm betting all the other speakers here would too. And finally, be sure to visit the sponsors and exhibitors, because it's sponsors that make conferences like this possible. It would not be possible without the contributions of sponsors. You can follow the organization at The Data Geeks or at Data AI Summit. And then as we transition to the question and answer phase here, if you have any questions, we will definitely be around to answer them. If you're watching this video later, or if you want to reach out to me later, here is my contact information on the screen. Please feel free to reach out to me on Twitter. I'm SQL Bob, or you can email me at bob@bobpusateri.com. Also, if you visit my blog, which is bobpusateri.com, I have a contact page through there. You can reach me as well. And if you would like the materials from this session, they will be posted on the conference website. Also, if you go at the bottom of this slide here to bobpusateri.com/r/DPS2020, that will forward you to my GitHub repository, where you will be able to get the slides, the demonstration code, and the demonstration database I worked with today. Thank you very much for attending. I hope you enjoyed this session.